bank and the PIN entry device. They don't protect the customer's PIN or the magstripe details because these are sent in an unencrypted form. They're sent from the card to the PIN entry device itself. So if a fraudster can somehow circumvent the tamper-resistance measures, connect to the almost unprotected I/O lines and record these details, they can then capture the information, write it onto a blank magstripe. They used to be able to use it in the UK. They might not be able to use it anymore, but they can certainly use it abroad. And what we found is that the I/O lines are almost completely unprotected. It takes little more than a paper clip and some off-the-shelf electronics to connect to these, record the details, and then send them off to a PC. But when we've previously tried to show that there's been weaknesses in the UK banking system, the banks have always responded saying that this is purely theoretical, this won't work in the real world, there are other measures that we can't talk about, but that will definitely prevent the attacks that you're talking. So what we did is demonstrated it for real. We asked the BBC to get us a real chip and PIN terminal and connect it up to a standard merchant account, do some real transactions, and then re-record the details. And we filmed the results, and this appeared on BBC Newsnight. So I'll now show a 5 minutes or so video on the results that we found. The full copy of this can be found on, I think, Google Video now, and there's a link to it from my website. Could you turn up the sound? Oh, yes, you're right. Thank you.
Good evening. In a very short space of time, the system of chip and PIN, punching in a code number each time you use your credit or debit card, has become ubiquitous. The great advantage, we were told, was that it had such good security protection. How could anyone steal from us if only we knew the numbers which would make our card function? As Susan Watts reports, it seems we were naive. By the way, while they were filming this piece, our cameraman fell victim to the fraudulent withdrawal of £1,000 from his account by someone in Serbia.
These were once intact PIN entry devices, or PEDs, which Stephen and Saar bought on eBay for around £30, giving them free rein to explore the inner workings of each device. This one is made by a company called Ingenico and is among the most common of the PEDs in use in UK stores today, in shops including Boots, Asda and the Co-op Group.
We found ways in which we can get into that interface between the card and the processor, and we're able to read the data as it went back and forth.
It sounds simple enough in theory, but these PEDs aren't live. The real test is whether the attack works on an active terminal. Away from their workbench, we provided the Cambridge duo with a live merchant's machine and a real credit card to test out their theory.
Right.
So let's go for a transaction and see if it works.
That's right.
We're not showing you whose account it is, just as we've been careful not to show any potential fraudster enough that they could carry out this attack. So now we just check to see that you've actually managed to pick it up, yeah?
Yep.
So the researchers have read off the name of the cardholder, their account number and their PIN.
The attacks that we've shown have demonstrated that it's easy to get the PIN as well as the card data out of the chip and PIN terminal. And this means that simply holding your hand over the terminal is no good. In other words, the customer cannot defend himself or herself, no matter how astute and careful they are. Therefore, surely the banks must take responsibility.
By showing that chip and PIN terminals can be easily compromised, the Cambridge team should now have made it harder for banks to blame the customer. There's now enough doubt about chip and pin for the onus to be on the banks themselves to come up with the evidence that it was the customer and not the security of their chip and pin system that was at fault.
Well, with us now is Sandra Quinn of APAX, which is the trade body representing the card issuers and users. How many chip and pin machines are there in Britain?
Over 1 million. We have a lot of pin entry devices, and the important thing to stress from this piece is that we're not talking about a break of the chip and pin security overall.
Well, I think, according to that, we certainly are. How many of these Ingenico machines are there?
There's a large amount, but I think the important thing to stress is exactly what the Cambridge team themselves have said. This is a difficult fraud to do and to replicate in a large scale.
I never said
They did it by acquiring stuff on eBay.
Absolutely, and you can do this fraud. What we're very careful about saying is we don't deny this fraud can happen, but as we currently stand, there are more economically viable ways of fraud being undertaken by fraudsters, and that's what our real concern is at the moment.
You have known that this system is vulnerable for a length of time you're not prepared to disclose.
Well, let's clarify. The system is not vulnerable. Chip and pin is extremely
We've just
secure.
seen it's vulnerable.
It's not 100% guarantee against fraud.
So it is vulnerable?
No, there is no guarantee, 100% guarantee against fraud.
So it's vulnerable, by definition. If there's no 100% guarantee, it's vulnerable.
All fraud, all systems have an inherent level of risk.
Sure.
And what we have done is look at the risks there, undertake a risk assessment and make sure that we protect our customers as much as possible.
And why not?
Our cards are
In that
secure.
case, why have you introduced the new security devices?
Because one of the things that you have with chip and pin is a layer of protection that you can build upon. So as soon as you see a threat, you can continue to build upon that protection with new and additional protection. And that's what we've done with chip and pin. That's why this new card protection standard has come in this year. And that's why all the assessments that we do about terminals continually moves and is upgraded.
So despite the fact that new cards have enhanced security, the previous cards don't lack anything by not having it?
Well, I think the figures speak for themselves here. As the piece said, card fraud with chip and pin has fallen.
In Britain?
In Britain.
The problem isn't in Britain, though, is it? And you know that.
Well, one of the reasons that we're making a very strong case to ask countries around the world to introduce chip and pin to ensure that we're all operating on the same global standard so that we can make sure card holders are being protected properly.
Okay, so let's look into a little bit more detail about what was shown there. So here is the Ingenico PED again. That's what it looks like from the front, and this is what it looks like on the back. There's this extra compartment, and underneath there are slots to put SIM cards in order to extend the functionality of the device. And this compartment is normally not seen by the customer. There's a seal across it, but nobody looks at the seal. And also, there are these slots, and there's mounting holes that make sure the SIM slots don't move around too much, and these mounting holes go all the way through the tamper mesh. So it's possible for someone to put a paper clip through, as is shown here, hook on to the I/O line, the input-output channel, and then record the pin as it's going across and record the magstripe details. And even better, not only can we get this information, but we've got this hole in the case that the customer can't look at, so we can put a little device in here which records all the details and then sends it out over USB. The Dione PED isn't very much better. You do have to drill through the case, but because you don't have to open the case, it doesn't even attempt to trigger the tamper resistance measures. And then you have a wire that comes off here, and we built a FPGA board which does the translation between the ISO 7816 smart card standard and a serial port and logs all the information. It then dumps it out to a PC, and you can see on the right-hand side is a copy of the ATR, the answer to reset, the first bit of information that's sent between the card and the pin entry device. We've also got a miniaturized version of this device, which is just about big enough to fit inside the slot of the Ingenico terminal, and also it'd be not very hard to make it much, much smaller, so it would almost not be noticed. When the bank said that there are easier things for the fraudsters to do, what they were probably referring to is that there was an attack on the Trintec series of terminals in Shell garages in 2005. And this was used to, again, extract the magstripe details and the PIN. But what we've now heard about as happening even before this programme was published on television, that fraudsters were doing exactly what we were warning was possible. And the total sum of money is very hard to estimate, but one fraudster was accused of collecting enough details to commit £16 million worth of fraud. So this type of problem is costing a significant sum of money. But that's not the only type of fraud that's possible. Much simpler thing to do is called a double swipe attack. Although there is a copy of the magstripe details on the chip, if you actually want to get the guaranteed copy of it, then you read the magstripe directly. And this is a screenshot from a video where a fraudster was working for a supermarket, and what he did was took your card off you, as many stops are now doing, swipe it through the normal chip and PIN reader, and then swipe it through a second one that he had hidden. This then gets a copy of the magstripe. Then, either using a camera or just by watching, he can look at the PIN that the customer enters, and then use this for the standard attacks. Another more sophisticated attack is the relay attack. This was presented at the previous CCC, but to give a reminder for those of you who were there and those who weren't there, I'll very briefly describe how this works. So here, Alice, who is the honest card holder, wants to, say, buy a meal in a restaurant. But at the same time, there's someone, Dave, who is working in a diamond shop, and he's offering jewellery for sale. So the fraudster wants the jewels, and Alice wants the meal. So here's how you can set this attack up. So Alice puts her card into the chip and PIN terminal in the restaurant, but the waiter is working for the crooks. So this isn't a real chip and PIN terminal, it's just connected to a laptop. The laptop then sends the details to a second laptop, which is connected to a fake card held by Carol, another person working for the fraudsters. And Carol puts this card into the diamond store shop. So when Dave's terminal challenges Carol's card to say, "Are you a real card?" Carol just sends all the information back to Bob's terminal and to Alice's card, and then Alice's card sends the response back through this chain all the way back to Dave. So with this technique, it seems as if, from Dave's perspective, that Alice is buying jewels. Alice only sees the $20 pop up on her chip and PIN terminal, because that can display whatever she wants. But when she gets her bill through, she'll find out that apparently she was in Dave's jewellery store and she just spent $2,000 on a fancy diamond ring. So I've talked about 3 issues in chip and PIN. There are many, many more. And if this just affected the banks, then that would be more or less their own business. If they were willing to refund the cost of fraud because they don't want to roll out to a possibly more expensive, more secure system, then that's up to them. The problem is that often the customer has to pay the cost of fraud. So this is a copy or some snippets from a letter, also available online, that is sent from the Financial Ombudsman Service to a customer who's been the victim of a phantom withdrawal, explaining why he shouldn't get his money back. So the first thing they say is that the firm has provided an audit trail of the transactions disputed by you. This shows the location and times of the transactions and evidences that the card used was chip read. Now, what does chip read actually mean here?